Hello everyone, welcome back to the Tensorflow tutorial series this time. And last time we already built up one brand new neural network for yourself, and then we're going to talk about how many optimizers we have in the TensorFlow. So for the optimizer, the job is to minimize the loss, right? So if you search on the Google, then you just put TensorFlow space and optimizer, then it will show this page, and you can see under the trend it has optimizers, and in here we have 1 2 3 4 5 6 7 optimizers can be used to your program. So the most important one or most simple one is the gradient descent. If you use a partial data to fit into your training step, then this gradient descent becomes to a stochastic gradient descent. So you can use the gradient descent optimizer to do the job that you used in the stochastic gradient descent. Add data optimizer, and I always use the momentum optimizer and add-on estimate optimizer. And if you know the AlphaGo or the computer plays Atari, then you know they are using the RMS probe optimizer. So let me sum up. Just use, if you are a beginner, so you just try the gradient descent optimizer, that is fine for you. And if you are higher level, so you know all the difference between optimizers, then you can choose whichever optimizer you will use in your projects. And I will also talk about performance of those optimizers. So this is a typical learning process for all optimizers. I will show this link in my description. If you want to know more about those optimizer or how those optimizer works, then you can go to this link and have a look. This website compares the stochastic gradient descent with momentum, with NAG and other grades, other data, and RMS prop. So as you can see, the red color lines represents there is more error, or the error is higher. Then the blue color represents the error or loss is lower. So this one, the star is the global minimum in this project, and I don't know if this any local minimum, but all the machine learning is trying to get to the global minimum or local minimum in these lines, in these blue lines. Or in other words, all the machine learning is trying to start from a red area, then generally going to the most blue area. The stochastic gradient descent compared with others is very slow to get to the converge to the global minimum. But the momentum is based on, actually the momentum is just based on not only on the linear rates at this step, but also consider the linear rates on the last step or last few steps. So this one, the momentum is faster than the stochastic gradient descent. And other gray and other data or add-on optimizer, there are all different methods to describe the learning rates. All the optimization tool is to improve the individual learning rate for every weight and bias. So this is the difference between them. I'm not going to talk about this in detail, but if you're very interested in it, you can take a look of this website. I would link this website in my description. Just take a look. Or this time we'll just talk about different types of optimizer that you can use. Back to the TensorFlow website. So we'll talk about different types of gradient descent. So for the beginners, it's better to use the gradient descent optimizer. If you have experience in the machine learning or neural network, you will use whatever the optimizer you want. That is all for today. Next time we're going to talk about use the visualization tool that's provided by TensorFlow, we call it TensorBoard, to show the whole picture of neural network and show all details about your neural network. So we'll talk about it later. See you then.